Hello, and welcome back to another Orange Coast Mathematics video. In this video, we are going to be talking about graphing the tangent and cotangent functions, and we're going to see a lot of similarities in this video compared to the last video where we graphed sine and cosine functions. One of the differences, though, is that you'll notice that tangent runs from negative pi over 2 to pi over 2. Now, it keeps repeating in the same way that sine does, but it only takes a period of pi to repeat normally, which is why when we're calculating the period, we're going to do pi over b instead of 2 pi over b. We'll notice the same thing for cotangent. The period we have graphed here goes from 0 to pi, and so it's length pi by standard as well. The other thing that's different is that they're not waves. They're these sort of curves that approach vertical asymptotes. So they get infinitely close to, but do not cross these vertical lines. And they repeat. If I were to keep going, tangent would have another one, and there's another one, and they keep going on forever. But typically, we're just looking for one period, and that's what we're going to be doing in this video. So let's go ahead and get started with an example, and we'll see how similar it really is to the sine and cosine problems. So the first thing I'm going to recognize is this is 1/2 times the tangent of 1/3 x, just to really make it clear that that b value is 1/3. That means my period is going to be pi divided by 1/3, which is the same thing as pi times 3, and so I get a period of 3 pi. Now, in this problem, do we have an amplitude? No, there is no amplitude because it's not a wave, but we can still use that a to describe a vertical stretch or shrink. So our a value in this problem is 1/2, which means we're going to be using it's going to basically shrink. Instead of having a standard a value of 1, normally the a in front of the tangent is going to be a value of 1, we're going to get a value of 1/2 here. And we'll see how that translates. And of course, for the period, we can break that 3 pi into 4 pieces to get 3 pi over 4, of course, which is what we're going to be counting by. So let's go ahead and set this up. We notice the tangent is centered on the y-axis, so I'm going to sketch my y-axis right down the middle, and the x-axis down the middle, because there's no shifting in this problem. What else? We're counting by 3 pi over 4, so I'm going to go 1, 2 ticks to the right, and 1, 2 ticks to the left. This would be 3 pi over 4, and then if I double that, I get 3 pi over 2. This is negative 3 pi over 4, negative 3 pi over 2. And we notice together from negative 3 pi over 2 to 3 pi over 2, we get that period of 3 pi. It's important when doing this that you do sketch the vertical asymptotes. So I'm going to, at these sort of endpoints of this interval here, I'm going to sketch those vertical asymptotes. We use a dotted line because it's not actually part of the graph, but it indicates how the graph behaves. For these other guys, you'll notice in this original picture of tangent, the tangent of pi over 4 is 1, and negative pi over 4 is negative 1, as we saw in the unit circle video. So at 3 pi over 4, I would go up to 1, but it's not 1 in this case, it's 1/2. So I'll go here up and here down, and I'll make sure to label this positive 1/2 and negative 1/2. Again, labeling the axes is very important because a lot of these pictures are going to look very similar. And then I connect this. Again, a couple key things to recognize. It's important that you approach the asymptotes, but you don't cross. It's important you don't just draw a straight line because it's not a straight line, it's a curve. Also, notice here and here, the graph does not level off like y equals x cubed does. It still has some sort of increasing behavior there, and that's important as well. All right, let's go ahead and do the same thing with cotangent. You see that it really does proceed fairly similarly. So in this video, in this problem, we're going to do the same thing. We're going to graph one period. My period is just going to be pi in this case because there's nothing in front of the x. My a value is just going to be 1. I'm going to split that pi into 4 pieces for what I'm going to count by. And I do have a vertical shift in this problem. That -3 means I'm going to go down by 3. So I'm going to start my x-axis, my y-axis over here on the left. Why? Because we notice by default cotangent is from 0 to pi, and we're not doing any horizontal shifting. So it's still going to start there, and I'm going to have my x-axis. Because of this shifting 3 down, I'm going to start my x-axis a little bit higher here, I think. And I'm going to count by 1, 2, 3, 4 of these little pieces. We have to end up at pi, but we're breaking that into the 4 pieces. That's pi over 4, 2 pi over 4, which is pi over 2, and 3 pi over 4. And so I know that those are going to be my start and end point. So those are going to be my asymptotes. I get an asymptote at pi. I get an asymptote at 0. But now, because I'm shifting down by 3, I'm going to have a new equilibrium point like we did with the sine graphs. -1, -2, -3. So my sort of equilibrium point is going to be right along here. And then for each of these values, I follow the cotangent graph, which starts at +1, 0, and -1. And because a is still 1 in this problem, that hasn't changed. So it's going down here to a -4 value. And so to connect these, it works the same way. We're going to start at the asymptote, come through this guy, and then end up down here. Something like that. All right. And lastly, we'll move on to one more where we do have a little bit more of a shift. We're using cotangent again. So what do we have to work with here? We've got a period of just pi again. There's nothing in front of the x. I've got an a value of -2. I've got a shift of pi over 6. It's a negative. I'm subtracting it from the x, so it's going to be pi over 6 to the right. That pi, of course, is going to be broken into 4 pieces, pi over 4. And so let's set this up. Cotangent is already to the right of the y-axis normally, and we're shifting a little bit to the right, so that hasn't changed here. So I'm going to put this at the y-axis here. There is no vertical shift, so I'm going to leave the x-axis in the middle here. We've got we're going to be counting by pi over 4s, and we're shifting by pi over 6. So this is kind of interesting in that it's a little hard to get it to scale because this is over 6 and this is over 4. But it's just a sketch. We'll do the best we can. So I need to start with a shift of pi over 6 to the right. And then pi over 4 is going to be what I count by. 1, 2, 3, 4. And if I'm counting by pi over 4, what am I getting? I'm getting, I guess maybe we should do some fraction conversion here. Pi over 6 is the same thing as 2 pi over 12. And I'm going by 3 pi over 12 each time, because pi over 4 is the same thing as 3 pi over 12. So what are my units here? It's 2 pi over 12 is where I'm going to start, plus 3 pi over 12 is 5 pi over 12, plus 3 pi over 12 is 8 pi over 12, plus 3 is 11 pi over 12, plus 3 is 14 pi over 12. And we can reduce those if we want. 5 pi over 12, 8 pi over 12 is 2/3 of a pi, 11 pi over 12, and 14 over 12 becomes 7 pi over 6. Okay, and now we will just do what? We will drop the asymptotes. So I've got an asymptote at pi over 6, got an asymptote at 7 pi over 6. I'm going to start equilibrium here. A is -2. Okay, that's interesting. Cotangent normally starts positive and then goes negative, but because of that negative, I'm going to get a negative output first, and then after that, a positive output. So it's going to kind of look more like tangent in that sense. And so this is going to be up at 2, and this is going to be down at -2 where this happens. Again, really important to label your axes. And then so my actual graph itself is going to look something like this. So very similar overall to sine and cosine, just different sort of parent functions, different pictures you're starting with, but all of the transformations work exactly the same way. All right, if you're ready, you can move on to the next video where we will talk about graphing the remaining 2 trig functions.